Hello and welcome to this short video about the E3 Master in Climate Adaptation Engineering. My name is Rui. I'm an E3 Assistant Professor in Climate Action here in the Department of Civil, Structural and Environmental Engineering. So in this short video, I'm going to provide you with the context of this E3 Master, then I'll follow with an overview of the program, following also with or providing you with details on the different modules that are offered and on the industry-led research projects that are going to be part of this E3 Master. So let's start with climate adaptation and its needs. As outlined by the International Panel on Climate Change, the need for climate adaptation is a core part of addressing climate change impacts across all sectors of society. We know to do this and to deliver balanced solutions for climate adaptation, we need a multidisciplinary approach, and we also need a generation of graduates that are able to deliver effective climate adaptation solutions for the future. So the need for climate adaptation is going to come also across a range of sectors that need to incorporate climate adaptation at all stages of their project's life cycles. We know this because damages due to climate events have been on the rise, and there's evidence that they have increased in the past decades. So, climate adaptation aligns with national and international priorities, whether that is the Irish Climate Action Plan or the UN Sustainable Development Goals. What's then the E3 Master in Climate Adaptation Engineering? First, it's important to understand that E3 stands for Engineering, Environment, and Emerging Technology, and is a new collaboration between the Schools of Engineering, Natural Sciences, and Computer Science and Statistics here at Trinity College Dublin. The idea is then to educate a new generation of to create a new generation of graduates that in existing in new technology sectors with the skills and attributes that will allow them to lead the creation of change in the future. And this is where this E3 Master positions itself. It will create the new graduates that are able to create the change in climate adaptation in the future. Let's then have a look at the program. So this E3 Master is divided in three main phases, in which each one comprises approximately 30 credits. The first one runs between September and December, where students are expected to have core and elective modules and will be working to identify industry-led research focus. Then, in between January and April, students will continue to have core and elective modules and will start on the industry-led research project. And then in between May and August, the expectation is for students to complete their industry-led research projects. And this will include, as we are going to see later, placements in companies and close collaboration and close ties with the industry. So the idea is then of these E3 Masters to develop the graduates with the technical and practical skills to support climate adaptation in different sectors. In terms of modules, it has 80 credits of core modules and 10 credits of elective modules that are going to be on offer and that you can choose from. Then why Trinity College? So Trinity has international reputation as an institution that delivers world-class education, is consistently ranking as Ireland's top university and among the world's best universities. It has a long tradition of innovation, of innovative thinking, and features many leading experts in the field of climate adaptation that you can avail from interacting with. And it has excellent career paths. So whether we talk about employability, the alumni network, and it's all around education, where here you're going to be educated not only on the specialist skills, but also on the soft skills that will make you an all-around professional in the future. And of course, we have an exceptional campus, and we are located right in the center of Dublin City. So what are then the unique features of this master? One of the main major features is its interdisciplinary approach. So it's a combination of engineering, computer science and statistics, and natural sciences subjects. It's an E3 program which will provide you with increased opportunities for engagement between students from different disciplines. There we have other E3 masters. And it has a focus of collaboration with public and private sectors. So this through the industry-led projects. So in this program, you will have the opportunity to work in highly industry-led research projects that include, for instance, industry placements, and that are designed to solve real-world pressing issues. Let's look at the different modules then that are offered through this program. So in between September and December, you will have 5 modules. 4 of them are going to be core and 1 is going to be elective that you can select. These are Introduction to Climate Adaptation Engineering, Global Environmental Change, Advanced Spatial Analysis using GIS, Introduction to Machine Learning, and then we have an elective module. In Introduction to Climate Adaptation Engineering, you're going to explore climate change adaptation with a focus on infrastructure network, economic and societal risks. In here, students are expected to learn key concepts and methodologies to evaluate risks and identify suitable adaptation and measures for infrastructure systems. Key topics will include climate hazards, vulnerability and resilience, risk assessment, qualitative and quantitative methods, climate impacts on infrastructure and societies, and adaptation strategies and decision-making tools for this. Then, in global environmental change, you're going to explore and overview the root causes of climate change and how humans drive environmental and climate change. What are the interconnected processes in this, and what are the impacts in the ecosystems and society? So the core topics covered in this module include human influence on Earth systems, biogeochemistry of carbon and nitrogen, ocean circulation and climate transitions, ecosystem stability, rewilding, and mitigation measures. Then in advanced spatial analysis using GIS, so it's a module on geographic information system and its application to real world projects. What's the significance and importance of this tool and its role in communicating complex social, physical, and economic relations of climate adaptation. Key topics will include advanced GIS tools, network analysis, spatial data mining, environmental modeling, real-world spatial analysis projects, and interdisciplinary problem-solving and technical communication using GIS. Then, in Introduction to Machine Learning, it's a module that is going to introduce you to the fundamentals of machine learning, focusing on hands-on development in processing and analyzing complex data sets. So it's tailored for students with limited programming experience and emphasizes empirical tools like linear regression, support vector machines, and their utility to assess climate adaptation. So in this module, you're going to cover topics such as programming fundamentals for machine learning, dataset preparation, visualization, and cleaning, machine learning setups and performance evaluation, and applications of big data to climate change adaptation and urban planning. Then, in between January and April, you're going to have 6 modules, 5 core and 1 elective, similar to the previous. Now you have 1 extra core module. And these are going to be Climate Adaptation Engineering Challenge, the Adaptation Planning for Infrastructure, Civil Engineering for Sustainable Development, Life Cycle Assessment for Engineering Practice, Human Interactions with Biodiversity, and then you have an elective module also in this trimester. Starting with Climate Adaptation Engineering Challenges. So this is a module that is going to focus on real-world climate adaptation challenges through case studies with public and our private partners. So it's a challenge-based learning. So we're going to produce sustainable solutions while considering technical, economic, and environmental, social, and governance factors. And key topics covered will include the development of a shared vision and strategy for addressing climate change, how to conduct a literature review and develop knowledge mapping, what's design thinking and engagement with stakeholders, what's the role of it, and showcasing, of course, of climate solutions. So it's a model that's you're going to be focused on teamwork and how to incorporate the different parts of a solution to climate adaptation. Then we have adaptation planning for infrastructure, which is a module that is going to look at the major infrastructure networks and their resilience to climate hazards, focusing on vulnerability, robustness, and recoverability to deliver climate resilience from a physical, social, and economic perspective. Key topics will include the uncertainty assessment and its role in climate change and risk, modeling of vulnerability, robustness, and recoverability, adaptation solutions, whether these are nature based or soft and hard engineering approaches, then climate adaptation with flexible design options and best practices. Then we move to civil engineering for sustainable development. In this model, you're going to focus on water supply, sanitation, sustainable transport in underdeveloping regions while exploring climate impacts. So it covers topics such as renewable energy technologies and their role in sustainable development. In it, students are expected to examine climate engineering roles in achieving sustainable development goals for water, energy, infrastructure, and cities. Key topics covered will include sustainable water supply and sanitation in developing countries, health impacts of sustainable transport, renewable energy technologies and their application, and then conceptual models for solving civil engineering challenges. Then we move on to life cycle assessment for engineering practice, where it's a model that's going to be focused on life cycle assessment, as the title refers to. And in this model, you're going to be looking at approaches to evaluate sustainability of the sustainability of engineering products, systems, and processes. It focuses on carbon footprinting, circular economy transitions, environmental, social, and economic impacts. Key topics will include life cycle assessment methods and best practices, quantifying carbon and resource flows, evaluating environmental, human health, and societal impacts, and circularity, measurement, and assessment. Then we move on to human interactions with biodiversity, which is a model that is going to explore how human activities affect global biodiversity in its value to humans. Key topics will include biodiversity and ecosystem services, pros and cons of the natural capital approach, business cases for biodiversity initiatives and human wildlife conflicts, and strategies for mitigating biodiversity loss. Then finally, we go to the elective modules 1 and 2. So a range of 11 optional elective modules will be available for selection in both trimester and include Advanced Linear Modeling 1, Bridge Engineering, Climate Justice, Climate Change and Development, Energy Policy and Energy Storage, Sustainable Water Supply and Sanitation, Transport Modeling and Planning, and practical environmental assessment, environmental policy, smart ecocities of the future, water resource planning and climate change, wave and hydro energy and wind energy. Then, to conclude, we have an industry-led climate adaptation research project that is going to be developed along the full 3 sets of trimesters, and it's a 30 credits module. So it's a model that is going to offer real-world experience via industry-led climate adaptation projects where you're going to foster collaboration, professional skills, and career prospects. You will be able to take one of the 2 projects pathways, which in both cases are going to be closely aligned with industry needs. So it's the industry-specific project, and it could be linked to an identified organization, mainly with industry supervision. It produces a practice-based output, that's a case study, or independent research project linked to industry needs. Then again, this needs to be or is going to be quite tied to the industry identified need and can be co-supervised by academic staff and can consult with industry for guidance. And to conclude this presentation, I would like to invite you all to visit our course website, D3 Climate Adaptation Engineering, where you're going to find relevant information about this course, information such as admission requirements and so on. Also, would like to invite you all to visit D3 website and to check the significant opportunities that are going to be made available to our as E3 students through it.